right, so here's the next one, integral tangent of x dx. There's really nothing you can do the way that this is written as is. There's not like oh, just think of a function where tangent is the answer. If we go through all of the derivatives, like I have all my cards here, none of them have tangent as an answer. Like none of these have just tangent of x as their derivative. So that is not going to work. So what we're going to do is rewrite this so that we can do a U substitution. So I am going to rewrite tangent. Actually, let me start by asking you, because I know you guys missed this part last year, but some of you might know this, and I hate to say anything that I could just ask you guys. How could you rewrite tangent as something over something else? Do you guys know what that would be? What you can rewrite tangent as? I'm just checking to see if anyone knows it. We're going to write this as a fraction. Oh, super close. You're like right there. Very warm. There we go. Yeah. Or, oh, someone, this was to me directly, y over x, which is sine over cosine. That's what that means. So, all right, cool. Because it's opposite over adjacent. If you think back to like whenever you took geometry, your SOHCAHTOA, opposite over adjacent. So it's the y value over the x value, which is sine over cosine. So perfect. Nice job, guys. All right, I just wanted to throw that question out there and see what I got back. All right, so we're going to do a U substitution, and when in doubt, you always let U equal the denominator. If you just aren't sure, if you have no idea, just let U equal the denominator. All right, and so derivative of cosine is negative sine. So negative sine of x dx, and we're just going to adjust the negative sign, which if you wanted to, you could just erase it and move it over to the other side. But we're going to multiply both sides by a -1 to move that over. So we're going to replace sine of x dx with negative du. So negative is going to go out front. Du goes at the end. Whatever you didn't highlight is still there. So the cosine of x, which is u, but it's in the denominator, so it is 1 over u. And so that antiderivative is going to be negative ln of u plus c. And then we're just going to put this cosine of x back in for u. So it is negative ln cosine of x plus c. And I'm going to show you cotangent as well. If you don't want to write this one down, that's fine. I'm going to do it just really fast. I'm going to call this like 6b, just so you can see me do cotangent as well. It goes almost the exact same way. And I'm going to post these notes after. I'm just going to do this one really fast. Instead of sine over cosine, you would rewrite cotangent as cosine over sine. Tangent and cotangent are just reciprocals of each other. So I just wrote it as cosine over sine. And I'm going to let u equal the denominator. Again, when in doubt, just let it equal the denominator. And derivative of sine is cosine. Sorry, I got close to the edge of the paper there. So we don't need to adjust this one. We're going to replace the cosine of x dx. So there's no like adjustment number that goes out front. It's just du at the end there. And again, this sine of x is the denominator, so it's 1 over u du, which antiderivative is ln, and then you would plug sine of x back in for u. So here's my pep talk on tangent and cotangent. You can either do that every time or you can memorize them. That's your choice. And what I'm going to do now is write out all 6 of the trig integrals. Again, I'm not there next to you and I can't force you to write this all out, but it is my strong suggestion that you just write out all 6 of them. There's only 6. Oops, I forgot a dx. Can't talk and write at the same time here. I'm going to write out all 6 of them for you. And I think it's just good for you to have them all in your notes, all in one place. And also to make flashcards. So just take a minute and jot them down. I'm going to write down all 6. And we've talked about 4 out of the 6 already. So there's only really going to be 2 that are new here. I just worked these 2 out, and we've done sine and cosine. So 4 of them are you know, not going to be like new here. But I think you should write them all down at least once and then make some flashcards. And I'm going to show you my flashcards I have. We'll go through them. Again, I warned you, it's cut and dry and sort of boring, and it involves memorization. But we got to get through it. All right, so for sine and cosine, I kind of just said like, hey guys, think of a function. If you did the derivative, you would get sine, like that's the answer. And so that one would be negative cosine plus c. The reason the negative is in there is because the derivative of cosine is negative sine. So we would need negative negative to cancel that out so that this would be positive. For this one, that would be sine of x plus c. Derivative of sine is cosine. So the derivative of this gives you this. And then tangent and cotangent, I just worked out. Again, you can either just flat out memorize them, or you can work them out like I just showed you. You can rewrite tangent as sine over cosine. And you can rewrite cotangent as cosine over sine. So these 2 you can kind of just figure out. These 2 you can work out. You can do a U substitution. Cosecant and secant, you're going to have to just flat out memorize, and they are sort of weird. So let me write them out, and then we'll talk about them. These are the 2 that you kind of just have to memorize them. Secant is ln secant of x plus tangent of x plus c. These all have a plus c at the end. And then cosecant is negative ln cosecant of x plus cotangent of x plus c. So do you remember how when we did the derivatives, secant and tangent were buddies? They kind of go together. Well, they still do. They're still buddies. And then whenever we did the derivatives, cosecant and cotangent kind of went together. Well, they are still buddies. So that's kind of how I tend to remember those. I don't know how to tell you to remember them. How your brain works is kind of between you and your brain. But I would make some flashcards. I would just make them and practice them. So this is my suggestion to you. Memorization is not something that I can teach. I can present it and give you suggestions and say here, and encouragement and say here, do this. But when it comes to memorization, ball is kind of in your court. I can't force you to memorize. All right, so we're going to do one more question. And this is what James was asking about just a minute ago. Will there ever be boundaries if there's trig? And so I just want to do one that does have that, so we can do some unit circle. So that is integral from pi over 8 to pi over 4 cosecant of 2x dx. So we're going to let u equal the guts of the problem, the inside stuff. So u is going to be 2x, and that derivative is 2 dx. And I don't have a 2 out front here in the problem, so I'm going to adjust with a 1/2. And so the only thing that you get to highlight is dx, but that's okay. So 1/2 goes out front, du goes at the end. Whatever you didn't highlight is still there. So cosecant of u. And then we're going to adjust the boundaries. Again, it's easy to do. You just have to plug them in for x right here. So if you plug in pi over 8, when you multiply that by 2, you would have 2/8, which would reduce to 1/4. So this will be pi over 4. And if you plug in pi over 4, you would have 2/4, which will reduce to pi over 2. So yes, there will be trig that has boundaries, but there'll be, angles on the unit circle. So stuff that you'll be able to evaluate. Or if they weren't on the unit circle, you would have to be allowed a calculator and you would, just type it in. Oh, by the way, where do you type these in? Not that you should be, you need to be able to do them by hand, but if you do type in an integral, do you guys remember what menu that's in? How do we get to that? Well, you even remember the number. Nice job. Math 9. Cool. All right, so this antiderivative, you do kind of just have to memorize this one. Cosecant is negative ln cosecant plus cotangent. Now, we won't put a plus c because this has actual boundaries on it that we're going to evaluate, so we won't have the plus c on this one, but it is negative ln cosecant plus cotangent. So this will be 1/2, it's going to be negative ln cosecant of u plus cotangent of u, and we're going to evaluate such that pi over 4 to pi over 2. All right, and so this is going to be upper boundary minus lower boundary. I left a lot of room because this is sort of a lot here. So first we're going to plug in pi over 2. Here's our unit circle. Hey guys, where's pi over 2? Up, down, left, or right? Find me pi over 2. Where's pi over 2? Good, nice job, up here. Okay, so we're going to have negative 1/2 ln cosecant of pi over 2. Cosecant means you're going to flip the y value. It's the reciprocal of sine. So that's 1, and the reciprocal of 1 is 1. So sine is 1, cosecant means you flip that or reciprocate that. So we just get 1. Plus cotangent of pi over 2. Cotangent is cosine over sine or x over y, however you want to think of that. 0 over 1 is 0. So this was negative 1/2 ln, and then we plugged in pi over 2. Cosecant of pi over 2 gave us 1, cotangent of pi over 2 gave us 0. All right, minus, and then we're going to do the exact same thing with pi over 4. So that's negative 1/2 ln, and I will draw pi over 4 for us. The sides of the triangle are both square root of 2 over 2. So cosecant, that means you're going to flip the y value or reciprocating sine. If you flip this over, you're going to get square root of 2. Plus, and I saw a question come up. Let me just finish this because I'm so close to the end of this problem. I just want to finish this thought and then I'll answer that for you. All right, and then cotangent is cosine over sine or x over y. Since they're both the same, anything over itself is just going to be 1. All right, and then here, 1 plus 0 is just 1. So you get ln of 1, which we talked about earlier, this block. Ln of 1 is 0. So this entire thing is just going to go to 0. So that's gone. That's kind of nice. These negatives cancel. And so we get 1/2 ln of square root of 2 plus 1, whatever that is. I dropped the absolute value because this would be positive anyway. So that would be your final answer. Now, the question that's in the chat is on the exam, how can you leave it? So there's 2 different answers to that. If it is free response, you don't have to evaluate anything. So you could leave it as 1/2 or negative 1/2 ln cosecant pi over 2 plus cotangent pi over 2. Like you wouldn't have to do anything. However, if it is multiple choice, you have to go the whole way because they're going to simplify all the choices down. So this is still an important skill because you would not be able to pick your answer choice for multiple choice if you didn't simplify it down the whole way.